I'm delighted to introduce Michael Benson. I've known Michael for 25 years, and we met, we were both living for a while in Middlebury, Vermont, and Michael was a photographer and an artist and an aspiring writer and filmmaker, and he was up for anything. And I remember I mentioned to him, I know this guy, he's planning this boat trip to sail a boat from Maine to Estonia and make it a peace sail. It was like 1989, 1988, right?
Yeah.
And he's looking for crew members, and Michael said, I'm going. And you did it. He went off, he sailed on this really rudimentary looking sailboat, and, and he survived to tell the tale. And since then, Michael has been doing an amazing, wonderful collection of things. He made an art film, or an art documentary film called Predictions of Fire about an exciting art movement in Slovenia in the 1990s. He's working on, just finishing out his 5th book, which is called Cosmigraphics, Picturing Space Through Time. And it's due in fall of 2014. And it focuses on non-photographic representations of the universe throughout history, starting in 2000 BC and going up to the NASA Hubble spacecraft images. His book Planetfall, which came out in October of 2013, just last fall, right?
Yeah, no, 12.
2012, is this gorgeous, and you're going to see images from it today. I was walking through Dulles Airport about a year ago, and I see on the wall Michael's images. He's had exhibitions at the Smithsonian and different places, including Dulles Airport, of these gorgeous images that he's grabbed from telescopes that are aimed at the planets, and he's pieced them together, and he'll tell you more about it. But they enter the realm of abstract art in many ways, and they're super exciting. And so you'll hear more about that today, and I'll just a few more things about Michael, and I'll hand the podium over to you. But he writes a lot where he brings the arts and sciences together, and astronomy and history together in exciting ways. And he gets his work published in fantastic venues for this kind of exploration, including the New Yorker, the Atlantic, Smithsonian, Rolling Stone, International Herald Tribune, and you've won awards for the best American science writing in both 2004 and 2014. So I'd like to hand the podium over to you. I'm delighted to have you. Thank you.
Thanks. I'm going to turn this light off. Hey, Kate, thanks so much. Really appreciate the invitation to come here, and I really appreciate being here. So, can you hear me okay, by the way? Okay. So I want to start with this. This quote is going to be at the top of my new book, which I'm just barely finishing now. And I'll just read it so that I make sure it's on screen long enough. In the universe now, there was no longer a container and a thing contained, but only a general thickness of signs superimposed and coagulated, occupying the whole volume of space. It was constantly being dotted minutely, a network of lines and scratches and reliefs and engravings. The universe was scrawled over on all sides, along all of its dimensions. There was no longer any way to establish a point of reference. The galaxy went on turning, but I could no longer count the revolutions. Any point could be the point of departure. Any sign heaped up with the others could be mine. But discovering it would have served no purpose, because it was clear that independent of signs, space didn't exist and perhaps had never existed. So the reason I love this quote is that it really puts into perspective the way we engage with the universe. We have to have a mediation, a type of mediation. We can't just, you can just perceive it, of course, but in general we need mediation. So this is a 10,000 light, this is an image, whoops, wrong image. Yeah, so this is the 10,000 light year distant Carina Nebula. So Calvino's observations capture the absurdity, but also the absolute necessity of the ways that we attempt to comprehend a subject as immense as the universe, not to mention our existence in it. These ways are utterly necessary because independent of signs, space may as well not exist in the first place, as he says. Just as without language, we really wouldn't have any thoughts in our heads. But these ways are also absurd. They're entirely absurd because they're always doomed to fail. And I would submit that this image of the Carina Nebula is an excellent example of that. As one of Calvino's innumerable signs heaped up with the others and therefore doing its bit to define space, it's both necessary and absurd and even preposterous. It's absurd because it's really a fool's errand to try somehow to capture and present the volume of space and time referenced with this picture. We're talking about a volume encompassing not only the 10,000 light years between us and the Carina Nebula, but also the many hundreds of light years defined by the distance between the top and the bottom and the left and the right sides of the picture. And this is just a very tiny, tiny percentage of the Milky Way, let alone the observable universe. So that's quite a staggering volume of space and time, and this photograph attempts to compress it down to a two-dimensional surface. Apart from having no dimensionality to speak of on its picture plane, it's a surface that in its incarnation as a photographic print is only about 8 feet wide and 4 feet tall. So this makes it one of the largest photographic prints you can actually make, and if you stay with the photographic process, chromogenic print rather than inkjet. But it's still, you know, small compared to the subject, obviously. This is the print in a dedicated gallery space at the Worcester Art Museum, where it is right now. So I'll leave the Carina Nebula behind for the moment and get back to it a bit later. I've spent much of the last decade, as Kate said, taking image data acquired for scientific research by interplanetary spacecraft and also the great space and land-based telescopes, and essentially making the case that with some curatorship and image processing, it belongs as much to the history of photography as it does to science. And I've been presenting the results in a series of illustrated books for Abrams, New York publisher of art books. This is my last book, the one Kate mentioned, came out in the fall of 2012, and I'm finishing my latest right now, as I said. So there are these vast archives in which the entire visual output of the great interplanetary missions are stored. And planetary scientists of various types go in there looking for what they need, to back up their theories. So we have geologists, atmospheric scientists, rings specialists going in there. And as a photographer and a filmmaker, I go into the same archives and I look for a kind of a different type of discovery. This is a true color mosaic of a mosaic composite image of Jupiter's innermost large satellite, Io, which is the most volcanic object ever observed. It's true color. It was assembled from raw frames taken by the Galileo spacecraft in the late 1990s. So I'm basically looking for aesthetic discoveries in the archives. And when I find a promising subset of this data, image data, it's grainy black and white individual frames, I start assembling it to see if I can come up with something that's truly interesting. So this mosaic composite photograph is of morning fog in the Valles Marineris canyon system on Mars, taken in May 2004 by the European Space Agency's Mars Express orbiter. And it's actually made of multiple black and white frames, which are composited and assembled and rendered in color. So apart from books, I'm also presenting the results in the gallery context. This is part of my second solo show at the Hasted Krautler Gallery on 24th Street in Chelsea. The show had more than 20 framed prints up from January 24th to March 9th of last year. So you see in the middle is that picture I showed you earlier. So I want to get into the backstory, so to speak, of this activity. In the beginnings of recorded astronomy, all observations of the heavens were necessarily naked eye observations. We didn't have telescopes. This is an Assyrian star chart, which was found in the library of a king who ruled more than 2,600 years ago in Mesopotamia. And you can see data representing the constellations arrayed out from a central point. So this is a perfect illustration of what Calvino was talking about, the network of lines and scratches and reliefs and engravings intended to bring the universe into existence. The Babylonian astronomical diaries, which are a record of systematic observations of the sky, extend from the 8th to the 1st century BC. The work of the Mesopotamian astrologers represents by far the longest continuous scientific record of any kind in history. Modern science is half as long as that. But of course, as today, there was the necessity to store the data in as portable a form as possible. This is one of the most stunning single condensed records of Babylonian astronomy. This copy belongs to the British Museum, and it's less than 5 inches high. When I saw it at an exhibition in Florence a few years ago, I was really shocked at how contemporary this miniaturized condensation of data looked. It's full, as you can see, it's full 5 inches, is entirely packed with cuneiform incisions regarding the Babylonian constellations. They're so dense and linear that to me, they look a lot like a silicon chip. So you get a really strong sense on looking at the thing that our contemporary concerns are much the same as theirs were. It's only the medium that has changed. But I wonder if something like the silicon chip on the left has any chance of, of keeping its data for remotely as long, even 1/100th of as long as the 2,200-year-old clay tablet on the right. So with the invention of the telescope in 1608, optically assisted observations of the heavens became possible for the first time. So here Galileo Galilei is showing the Doge of Venice, Leonardo Donato, how the instrument worked. Galileo was demonstrating the telescope during the day, and it's oriented towards the horizon and not the sky, because its utility in naval warfare was a lot more important to the ruler of a large maritime empire than doing frivolous things like discovering moons of Jupiter and stuff like that. So essentially with the telescope, we had the lens of a camera, but no back or for a photographic plate or digital CCD chip. Telescope-assisted observations of the heavens predated the invention of photography by 230 years. And this means that astronomers had to depict what they were seeing with drawings. This is one of Galileo's drawings of the moon from 1610, converted into a print for use in his book Sidereus Nuncius, or Starry Messenger. So by about 250 years after Galileo, or the mid-19th century, the telescope had expanded radically in size. This 58-foot-long telescope was built in Northern Ireland, which could boast at best 60 good viewing nights per year. And it had a 4-ton mirror. It was called the Leviathan of Parsonstown, and it was built by William Parsons, the 3rd Earl of Ross. It was the largest telescope in the world from 1845 to 1917. Which is really quite a stretch. The mirror was made of an alloy that tarnished fast, but money was no object for the Earl, and he simply had 2 4-ton mirrors made, which he regularly switched so that one could be polished back to maximum reflectivity by the servants, while the other one was in use. So that's 8 tons of highly tarnishable metal alloy in one of the worst locations for astronomy in the world. But still, despite that, he did, with a telescope of that size, for the first time, the structure of what had been known to be nebulae could be glimpsed for the first time. And so the Earl of Ross saw this very intriguing spiral structure in one of these nebulae. This is a mid-19th century drawing by Parsons of what was then called the M51 Nebula, which is now understood to be a massive spiral galaxy more than 23 million light years away. So there it is flipped into negative form to better represent the way it would have been seen through his telescope. Now, Parsons' drawing created a sensation when it was widely reproduced. And by 1882, it had made its way into a popular French book on astronomy, one copy of which was thought to have been acquired by a certain mental institution in the south of France. So here we have the result, or one of the results of Parsons' observation. It's now quite widely accepted that the Earl's careful drawing of this, what was thought to be a nebula, but it in fact is a spiral galaxy, made its way via this French book popularizing astronomy into the center of the single most famous artistic rendition of the night sky, which is, of course, Starry Night by Vincent van Gogh. And it may well have been the chief inspiration for it. I was actually researching this for my new book, and Van Gogh was really into scientific discoveries, and he really made it a point. He wrote his letter, excited letters, you know, his letter. He wrote his brother excited letters all about his research into astronomy and his friendships with astronomers, and so it's pretty clear that that's what happened. So again, this is due to the reproduction of a sketch made before the use of photography was possible in astronomy. So from Galileo until about the last quarter or so of the 19th century, a steady hand and some rendering talent on the part of the observer were major assets in astronomy. By the late 19th century, we saw the emergence of such astronomer illustrators as the French expat Etienne Trouvelot, who from 1870 to around 1880 produced a series of really very interesting and well done paintings of planets, such as this one of Jupiter, as well as other phenomena visible through the high-powered telescopes of that period. Trouvelot was also fascinated by solar prominences, which you can see here. In 1872, he was invited onto the staff of the Harvard College Observatory, which actually I've been spending a bunch of time at lately as I work on my new book. By 1881, Charles Scribner's and Sons had released a limited edition collection of his best color illustrations of astronomical phenomena, one of the first serious attempts to publicize the results of observations made using technology developed for scientific research, but essentially presented as belonging to the arts. The New York Public Library is one of the few places where you can see the full set of these very rare drawings that he made, lithographs. So here's a closer view of that. I love the fact that if you look closely at the bottom, I don't know if you can see this, but you can see that the two prominences in the image span 100,000 miles, or more than 10 times the diameter of Earth. So these pictures really played a role in making the public aware of what was being discovered about our scale in the universe for the first time. So here's Trouvelot's depiction of Mars. By the way, Trouvelot was also an amateur entomologist, and he will forever be best known for the fact that he released by accident gypsy moth larvae from his home in Medford, Massachusetts, and to this day they cause hundreds of millions of dollars of damage annually to the hardwood trees in the eastern half of the U.S. He was also a very talented artist, but okay. So by the mid-1880s, photographic emulsions had improved to the point where they could be used in astronomy, and new stars were routinely being discovered using photographic techniques. So since then, virtually all astronomical discoveries were the result of the marriage of the telescope and photography, be it plate-based, as here, that's a photographic plate the guy's holding, or digitally, you know, CCD-based, as most astronomy is today. So this is a typical photographic view of the moon from Earth. And that's a 19th century, early 19th century drawing of the same. So you see the crater in the south. It's actually a very good drawing. So this is a jump all the way forward to one of the ultimate expressions of contemporary CCD-based photographic astronomy, which is this particularly astonishing view of the Whirlpool galaxy seen by the Hubble Space Telescope. And that's the Earl of Ross's drawing of it from the mid-19th century. I think he did a pretty good job. Okay. By the early 1960s and the arrival of spaceflight, a new kind of photographic astronomy became possible. This is a graphic depiction of one of the mid-1960s lunar orbiter spacecraft, which were used by NASA to scout the moon before astronauts landed there in 1969. Now, with unmanned robotic spacecraft, for the first time we could physically send telescopes and cameras directly to the object being studied. 5 of these spacecraft were launched to map the moon between 66 and 67. Actually, we were just discussing earlier. It's very interesting. You know, this was before any kind of efficient possibility of transmitting TV signals even. And so these spacecraft had little photographic development labs within the spacecraft. And as they were orbiting the moon, they processed 70 millimeter film, and they scanned it, and they sent the information. So they were orbiting, they were lunar orbiting darkrooms, basically. So this picture was taken by Lunar Orbiter 2 on May 19th, 1967. And as far as I can tell from my research, it's the first image of the crescent moon, effectively the full moon, not full, but you can see that most of the moon would have been in that frame, and Earth within the same picture ever recorded. It wasn't released to the general public at the time, although I would submit that it's really one of the more extraordinary images from the early history of spaceflight. It wasn't released because there was the process of scanning the negative resulted in a so-called Venetian blinds distortion. And so I spent about 10 days cleaning up that image way back in, I think it was 2001 or something, in order to make it readable, as I would hope it is there. So almost a year after that lunar orbiter shot was taken, on April 2nd, 1968, Stanley Kubrick's film masterpiece, 2001: A Space Odyssey, gave the world a color Earthrise over the moon for the first time. So with that sequence, which is at the very, very beginning of the film, with the kettle drums and so on, Kubrick and his close collaborator, Arthur C. Clarke, who I got to know towards the end of his life, and I met him in the year 2001 actually, correctly intuited and predicted the power of another image. This is the first color Earthrise picture and was taken by the Apollo 8 crew on December 24th, 1968, 8 months after the release of 2001. It can be really hard to look at this picture with fresh eyes now, but I think the existential impact of that photo can't be overestimated, and it still echoes today. It has been called the most influential environmental photograph ever taken, although we could use a new dose of that these days. I actually think it's one of the most influential photographs of any kind ever taken. So I just want to jump back again to 2001, which is, as you probably gather, one of my favorite movies. This painting by space illustrator Robert McCall was used as one of the posters for the film. In fact, I have, I'm happy to tell you, I have a signed poster, reproduction of that poster up on my wall, signed by Arthur Clarke in the year 2001. If you look a little closer, look carefully at that for a second. Is there something strangely familiar about the super thin tablet computer with the keyboard on its screen? This is in '68. So again, that's a 1968 prediction of what was supposed to be in common use by the year 2001. In 1968, computers filled entire huge rooms, and they were only in major research universities and the Pentagon. So Kubrick's little group of well-funded prognosticators came up with the iPad in '68 without the technology inside, of course. And in fact, by the way, Samsung used some shots from 2001 when they fought Apple in court. There was no technology inside. So this is Jupiter and its moons as seen in Kubrick's film 8 years before any spacecraft flew by that planet and produced anything like this angle or this image. But still, as with Van Gogh's Starry Night, here you have the use of source imagery recorded for scientific research purposes, but being deployed in a work of art. And that's Trouvelot's depiction of the planet, again from the late 19th century. You can see the great red spot, which is this giant storm system, several times the size of Earth, and also two of the planet's moons in transit with their shadows on the face of the planet. And here's Jupiter from this last book of mine, Planetfall. This is an image taken by the Saturn-bound Cassini spacecraft on December 9th, 2000. And you can see Jupiter's satellite Io, the same one I showed you at the beginning, suspended in front of the planet. And as with Trouvelot's picture, you see the shadow of the moon right on, crisply on the face of the gas giant. Oops. Okay. So a few years ago, I went to the Metropolitan Museum of Art in New York, and I discovered this corner arrangement of photographs in a show called Between Here and There. So in the show was an early example of a handmade space photo mosaic. The individual photos in this particular example were taken from a TV transmission from the surface of the moon by one of the Surveyor spacecraft, which landed there before the arrival of astronauts in 1969. And by the way, I mean, last time I checked, the Met is not a natural history museum. It's an art museum, or it would be across the park from itself. So the inclusion of that photo in this show, I would say, made it clear that these images belong to the history of image making. It would seem self-evident, but it's not necessarily so. So this is an example of a much more recent image mosaic, which I put together, where you can still see the jagged edge. I assembled this image over the course of about a week from 66 raw frames sent to Earth by the Spirit rover, Mars Rover, between December 30th, 2005 and January 1st, 2006. I assembled it about a year and a half ago now. So that's a very big print. Yeah, there it is, okay. So I'm going to go back to the Carina Nebula as represented in my 2009 book, Far Out, where it's only 22 inches wide and 11 inches tall. So again, if you look at it rationally, it's completely absurd to try to somehow compress 10,000 light years of space and time into this teeny bullion cube of a photo. And I say space and time because, of course, 10,000 light years is a measure not just of distance but of time. It's a measure of the time it took for the light that was used to make this photograph to arrive in the vicinity of Earth and be captured by the mirror of the orbiting Hubble Space Telescope. So here's a wide context view of a part of the Milky Way galaxy, and the red arrow is pointing to the Carina Nebula. And on the left side, by the way, upper left side, you can see the center of our galaxy, which is that glowing orange, glowing yellow bulge there. Also below the arrow, all the way at the bottom of the picture, I don't know if you can see that, but those are the two nearest galaxies to the Milky Way, which are called the Magellanic Clouds. And this is a somewhat closer view of the Carina Nebula to the right. And we're closing in. Now, Carina is one of the brightest nebulas visible from Earth. So I just want to try to put that 10,000 light year distance between us and the nebula into perspective. The population of Earth around 10,000 years ago was about 4 million widely scattered people. That's considerably less than the population of New York City, which is not the biggest city in the world. So we're talking about a period before the earliest pictographic proto-writing. We're talking about a period when the Neolithic revolution was just happening, beginning to happen. Agriculture had started, but there was no ceramic pottery. Stone tools were still in use. And it's not that far away. So this is a closer view still, meaning it's a narrower field of view, since all of these images were taken in the vicinity of Earth, either orbiting, from an orbiting space telescope or from the surface of the Earth. They're not literally closer, they're just narrower fields of view. So again, I was talking about earlier about how trying to compress this volume of space and time in a photograph is really a fool's errand, but it's also an essential thing. This is a photograph. This is a composite of multiple exposures taken in visible light wavelengths by the European Southern Observatory from Chile between 1999 and 2003. In fact, these observations provided the data that I used, the color data I used to infuse the Carina Nebula image that I showed earlier with correct colors. So while the detail in the image that I showed earlier is the result of the Hubble Space Telescope's observations, the color that I used for that image is from this set of observations from another telescope taken at another time. And it's complicated to explain why that is, but basically the Hubble image was released in what they call representative colors, meaning it wasn't connected to what we might see if we had meters wide lenses in our eyes and could look in time exposure. This is true color. So this is red, green, and blue, this one. So I was talking about how ridiculous it is even to try, but that it's necessary. So how are these attempts to capture parts of the visible universe necessary? I think Calvino caught the essential paradox in cosmicomics, meaning the comedy of the attempt, which is always doomed to fail, but the necessity also. Among other reasons, he implied that it's necessary because independent of signs, space didn't exist and perhaps had never existed. So in other words, although we're doomed to failure, it is absolutely required that we make the attempt. And in fact, each such attempt will take us to a next level from which we can proceed to attempt again and fail again, but in the process learn more and on and on. Or to switch from quoting Calvino to quoting Samuel Beckett for a moment, try again, fail better. And that takes us right to the heart of the scientific method, the artistic method, and ultimately the comedy of our mortal existence, tragic comedy of our existence as sentient creatures on this little speck of matter orbiting a pretty insignificant star in the Milky Way. So speaking of which, this is the location of the solar system in the Milky Way. It's on the best current idea we have of what the Milky Way looks like, the structure of the Milky Way. So you can see us there in what we now call the Orion Spur, halfway between the Sagittarius and the Perseus arms of the galaxy. And speaking of noble but failed attempts, it's highly unlikely that this map is accurate. In fact, it's probably less accurate than those 16th century maps of the world that represented California as an island and only an ocean where Antarctica is. But in order to get to the point where we have GPS tracking which can tell the NSA exactly where you are at any moment in time, it's necessary to try and fail and so on. So there you can see the Carina Nebula to the right of the solar system. See there on the right of the screen? Carina Nebula, that's the Carina Nebula. And here's the image of Carina again, which sort of takes us full circle. Independent of signs, space didn't exist and perhaps had never existed. Thanks. So if there are any questions, I would be happy to answer if I can. Mm-hmm.
When you make clear images for a gallery setting or for books, what kind of connection do you want to make to that? Do you want to give them a sense of wonder, insignificance? How do you hope to reach another human with the image and the power of it?
It always depends on what the scene is, what the image is. I mean, some of them are pure abstraction. They're like Rothko. I mean, they're radar images of Venus that are just unbelievably rich. I'm sure you're aware of those. And then others, I mean, with this image, this is just staggering vista. It has a kind of Renaissance painterly quality. It really depends. And with the images from the surface of Mars, I just want to get as close as I possibly can to how somebody on the surface of Mars with a large format landscape camera might capture it. It's really attempting. It's very 20th century, early 20th century photographers kind of quest. But that's just in that case. People have asked me, do I mess around with the colors and so on? Well, I do a lot of messing around with the colors in order to try to get it as close to what we might see as possible. Because at least with this body of work, it might be different for another type of work, but with this body of work, I really believe that it's necessary because we have so little experience with this subject matter. We have no direct experience, basically. I mean, some astronauts went to the moon. Beyond that, there's no direct experience. So I think that I mean, with it, as I was trying to say, I mean, with this body of work, I really try to get it as close as possible to what we might see. And then once I do that, then I use the standard bag of photographers' tricks, darkroom tricks, to try to get a really rich print. But the baseline is, what would it look like to us? And then if it's a black and white image, then then it's a little different story, not that much different. Yeah.
So I presume you talked about working at a Harvard lab and that you've interacted with a number of scientists who do physicists or whatever genres that do professionally. What kind of impressions have you got about the interplay between how scientists approach their raw material that you use for composite and what you might consider the popular image of space? Have you got the feeling that they have feelings on how space is represented, how their work is represented?
Well, it all depends on who. For example, I've met this really nice guy. His name is Zsolt Levi. That's a name right out of Buck Rogers. He happens to be the chief image processor for Hubble, Zsolt Levi, and they do a lot of. I think that they're doing great work, and they've been fantastic when it comes to outreach. There's no question. I mean, Hubble is the single most popular device NASA has, apart from the Mars rovers are pretty sensational too. But they do a lot of stuff that I don't necessarily agree with. That's the reason why I changed the colors of this image from representative colors to real colors, or what I would say are true colors. So we had one kind of discussion, Zsolt and I, about that. And then when it comes to working planetary scientists, there are many different kinds of scientists. I mean, basically, the aggregate opinion seems to be that people like what I'm doing because they know that it's good if there's outreach for, if people are captivated by what's being achieved by these expensive but not that expensive missions. Considering what we're achieving with these missions, they're really cheap. NASA has less than 1/2 of a penny out of the dollar of the federal budget, and they do amazing things with that. So, I've gotten some compliments there, and also I've gotten what almost amounts to fan mails from various planetary scientists, because they don't really have time necessarily. They're not necessarily all image processor geeks like me. They don't necessarily need to spend the time to make color composites. I spared you the details about how I make those things, but it can be very arcane, So some people have written me and said, "Wow, I didn't realize it looked exactly like that." Yeah, I don't know if I answered your question, but yeah.
Have you considered using light that is invisible, like radio waves or X-rays or?
Yeah, I've used some of the work that I played with, which I like best, is black and white prints of radar images of Venus. So that's, radar, it's not light. And then, you know, even with some of this material, for example, this image here, the Hubble image that's the basis of this image used filters that were outside of the visible bandwidths that the human eye could see. So it's a composite, actually. So there are other wavelengths in there. It's just that the color is from the true color, that other image I showed. Yeah. But it's also interesting you ask me that right now, because I'm about to start a project at MIT using an electron microscope. And that's going to go into, it's called nanocosmos, and it's going to go into natural design at sub-millimeter scales. And that's, instead of photons of light, which are much too large, we're talking about images based on subatomic particles. You know, that's what an electron microscope does. It fires electrons at the subject. So yeah, I am working in that direction.
Because then you have the issue of how do you map these things into colors? Then it's your own choice, exactly, nothing else, right?
Well, I don't do that. I actually love black and white photography, and so with the electron microscope, one thing I really don't like with electron microscope photography is false colored electron microscope photography. I haven't seen it done well yet. Maybe there's a way to do it. I like black and white photography. So I don't, you know, when I release a color image, the color comes from actual data. It's not made up, you know. Any other questions? In the back on the left.
I just, do you remember the first photo or series of photos or that made this your focus, like when you're looking towards space imagery?
My mom took me to see 2001: A Space Odyssey when I was 6. I'll confess. Okay, I'm out of the closet now. She took me to see it when I was 6, and she was a science fiction fan. And I don't know, have you seen that film yourself? 2001? Well, I highly recommend it, although seeing it on a TV or even a big plasma screen is already kind of like a sin. It should be on a big screen. Anyway, I remember following her down Broadway in '68 and asking her over and over, what did it mean? And her response was, I don't know. But that was my first exposure, conscious exposure to a masterpiece in any medium. And, you know, and it was really one of the very few masterpieces in any medium that really deals with space. You know, we're very self-absorbed as a species. We don't really look up that much, you know. And so I think that really sent me on my course from there. And I did a lot of other stuff. I mean, I've done reporting for the New York Times, and I've done documentaries about art movements in Central Europe and various things. But I've always found what we're doing in space and what we're discovering about space, and I mean, even calling it space is kind of absurd. We're in space. We live in space. It's just, we have to understand it that way. I've always found that fascinating. And then, of course, you know, during that period, we were landing on the moon. I mean, the United States was landing on the moon. Human beings were going to the moon. That's pretty amazing. So those two things probably resulted in me being the geek that I am today. Yeah.
It seems like you're conflating the ability to represent in some compelling way space with its existence, with its very existence in human terms.
Calvino was too, yeah.
Could you talk a little bit more about that?
Well, that's interesting. You know, my new book, it's called Cosmigraphics, and it's looking at centuries and centuries of attempts to present something so huge and so staggering and hard to understand in an understandable way, you know, and typically, you know, in a size scale that's you can hold between your hands. Now that's pretty amazing, you know, and the fact is that it's like there's something miraculous about the fact that we brought it off over and over. I mean, not for the whole story, although one of the pieces that I'll have in my book was an amazing attempt to depict all of space-time from the Big Bang till now in one image. It's called a conformal map of the universe. And it was produced by some geniuses at the Harvard, you know, at where Einstein was, at the Harvard Institute of Advanced Study at Harvard. I mean, how else can we try to grasp the universe? You know, okay, we're talking about it and we're using words, you know, to talk about it. So that's how we're engaging with it, by talking about it right now. And then there are images, and I don't know how else. I mean, there is another way, of course, which is you go to an Adriatic island in the summer and you lie on your back and you look, you know, which I did last summer. And that's a pretty nice way too. That's like looking at a Rothko painting without any knowledge of Rothko, or, you know, trying to turn off everything you know and just absorb it. I don't know how else. But the subject of cosmographics is really how we have tried over centuries to do that. Yeah. Uh-huh.
One of the things I might comment that a member of the audience made a little earlier is, I understand you're interested in history of the image in space, and about how technological developments have allowed the invisible to invisible to be able, and how that, you know, is expanding our understanding of the universe, like one is just paraphrasing Paulina along the lines of it. So why is it that, if I understand you correctly, you arbitrarily descended a slightly visible spectrum when rendering this elongated, you know, these vast arrays that these telescopes have?
Yeah.
I mean, after all, you could be revelatory to create images that are from the non-visible spectrum, granted that there's the challenge of trying to get people to understand that we're having a visual representation of the invisible before that.
No, you're absolutely right. It's a really interesting, I mean, I think I touched on that earlier. You know, I mean, maybe I can answer by saying, when I see NASA release a false color image, let's say of Saturn, where it's purple and then you have bright red in a circle around the poles, because that's the aurora, you know, I really wince, because even though I understand full well that what it's showing is the electrical fields and auroral activity, it's leading a lot of people to think that we have a planet out there that looks like that, you know. But having said that, I mean, you know, for example, the radar images of Venus that I mentioned that's something we would not see. We can't. The reason we're using radar is because we can't see it in visible light, because Venus has such a dense atmosphere, and it produces something extremely beautiful. I mean, you know, very rich, almost like Asian scroll paintings from the Han Dynasty. Some of these images look like. So I have gone there in that way, you know, and maybe in the future I will continue, because, for example, in this new book, I've been in touch with a researcher in Hawaii. His name is Brent Tully, and he's one of the leading researchers of large-scale structures of the universe, galaxy walls and filaments and so on. And he's working with a team in Paris who are using the French National Supercomputing Center to visualize large-scale galaxy structures flowing towards gravity wells. And so they've been sending me videos and high-resolution stills from their visualizations, which are false color, and they're not even remotely, we can't begin to grasp. I mean, we can't begin to see, I should put it that way. We can grasp through these images. We can't see that kind of thing. No way, you know. And they're of course they're false color. They have red lines and black lines and everything's in different colors, and it's just utterly fascinating to me as an image, and it's way outside of anything we could see. So, yeah. Yeah.
Astronaut Alan Bean came back from the moon and then spent the rest of his life painting what he had seen there in a Robert McCall kind of realistic manner. Because he didn't like any of the way it turned out in the photos he had taken while he was on the moon with his own eyeballs.
Right.
Have you spoken to other folks who are similarly unimpressed with the ability of photography to capture what they themselves experienced and saw?
Well, not that many people have actually gone beyond low Earth orbit. I haven't been lucky enough to talk to any of the Apollo guys. Friend of mine is the lead historian, really, of Apollo, Andy Chaikin. He knows all of them. Alan Bean's show preceded mine at the Smithsonian a few years ago, so I saw the paintings. You know, I think that it was an interesting effort. It's very traditional realism, which is exactly what the Washington Post said about my stuff. You know, it's a fairly traditional realism. Well, yeah, I mean, I'm trying to, but it's mind-blowing, the subject, you know, sorry. So, I don't know. I don't know exactly how to answer that. And I can answer it by saying I haven't spoken to anybody who, I've spoken to some astronauts, but nobody who has who's gone to another world. Yeah. In fact, part of the reason I'm doing what I'm doing is to try to present what it might look like if we could go. Yeah. Any other questions? Well, thanks a lot for coming. I really appreciate it.